Have you seen people who never get sick and others who always are? Well, the first ones really need to thank their immune system. But what is that?
Imagine yourself as Earth, and all infectious agents were like aliens that wanted to invade it.
To prevent it, you have a very specialized army whose main purpose is to eradicate the invaders. Like every other army, they need a strategy to win.
The defense is divided into 3 lines. The outer defense is the intact skin and the mucous membranes, which prevent the enemies from entering the body. The other lines are cells of the immune system, which are constantly scanning other cells for possible enemies with molecular sensors called pattern recognition receptors. If the first line is breached, then the battle begins. The first to identify a breach in the security are cells of the innate immunity.
Macrophages are huge sentinel cells which grab and devour pathogens by a process called phagocytosis. They will then present parts of the pathogens on their surface. Neutrophils are deadly white blood cells which release molecules called defensins that kill enemies and healthy cells in the process, by literally making holes on their cell membrane.
Then you have the heavy backups, which are cells of the adaptive immunity.
They are called lymphocytes T and lymphocytes B, also referred as T and B cells. There are 2 types of T cells. First, the T helper cells, which secrete signaling molecules called interleukins in order to activate autoimmune cells and enhance their multiplication. Then, T killer cells destroy virus-infected and tumor cells by disintegrating their membranes or inducing programmed death. Finally, B cells specialize into plasma cells, which produce large amounts of antibodies. Antibodies are little proteins that bind to every kind of pathogen, making them easy target for macrophages. This process is called opsonization. All along the battle, cells of the adaptive immunity can become memory cells. So, if they ever encounter the same pathogen that had once already activated them, the response will be much faster and stronger. You don't always get attacked by a foreign enemy. It can come from within. That's what cancer is. Cancer cells were once normal cells. By becoming malignant, their surface proteins changed and are recognized by the immune system, which then kills them. To prevent it, cancer cells develop several mechanisms, such as signaling molecules, which stun the immune cells, allowing the cancer to grow. That's where immunotherapy comes in. So, as you can see, the more precisely we know at a molecular level what happens with a specific type of cancer, the better we will be able to help our own immune system to fight against it, therefore improving the efficacy of the immune therapeutics and reducing the harmful side effects of the treatments that are available nowadays.